Tech Revision with Mrs. Swanee Pooh. Hello, back again with another video about finishes. This time we are going to be talking through there's actually a wide range of finishes that are used on metals. These are the following finishes that you need to have an awareness of. You've got the use of cellulose and acrylic paints. You've got some bit of chemistry coming into this video, so any of you that study chemistry or can remember any of your chemistry from GCSE, you may remember things like electroplating and cathodic protection, use of anodes and cathodes and all those fun things. As well as that, you need to know about polymer dip coating, galvanizing, powder coating, anodizing, and something called metal varnishing. So let's make a start. First things first, we'll start with the really easy ones. Metals can have paints applied to them, just like most other materials. It tends to be that you apply it to lower cost ferrous metals, like mild steel or low carbon steel, and it comes in a range of colours and textures, often needs an undercoat, but yes, metals can be painted, and that's quite a good one to say if you were asked about a finish that should be given to a product that's outdoors and it's a ferrous metal. Paint would be a completely acceptable answer. This one's quite a weird one, but metals can be varnished, just like timbers and things can be varnished as well. It tends to be that you use this finish because you want to be able to see the material underneath. So it tends to be used on quite attractive metals like copper and aluminium and brass, and it provides a clear layer and it gives a little bit of added protection from scratches, dents, all that sort of stuff. But those two are relatively simple finishes that can be applied to metals. Right, the next few are, I've got some videos to show you to make these really clear. The first one being dip coating. So these all, well, the next two involve the use of polymers being mostly heated and melted onto the surface of metals. So dip coating, really simple. The metal is heated and dipped into a almost like a bath of plastic powder. Normally that has some air going through it, so it kind of coats the metal really easily. I think it's called fluidized. The plastic powder, because of the heat on the metal, instantly sticks to it. And then the metal is returned to an oven, heated again to join the plastic to the surface and provide a nice shiny finish as the polymer cools. So I'm going to show you a very short video showing this process.
Fluidized bed powder coating is a process where a preheated part is dipped into a tank of fluidized thermoplastic powder, which is typically PVC or nylon. This creates a beautiful and durable conformal coating on the part. A fluidized bed is created by forcing air up through thermoplastic powder, making it flow like a liquid. This enables the powder to get into all the nooks and crannies of the part being coated. Typically, a fluid bed powder coated part is carefully preheated in a conveyor oven, dipped into the fluidized bed, reheated to make the powder fuse out, and finally cooled to room temperature. In some cases, the reheating isn't necessary, as the heat energy already in the part is sufficient to get the powder to fuse. Cooling is either done in air or water as required.
Okay, hopefully that video made that process clearer. You can see that it would provide lots of benefits. It can provide colour to metal products. It can provide protection, can stop metal products from scratching things. It can also provide comfort, like the grips on these tool handles. So yeah, has lots of benefits. This next one is relatively similar, but it has one key difference, that the powder is, rather than just being dipped into a vat of powder, it is applied with a almost like a gun, a powder gun, and the powder particles are electrically charged, so they literally stick to the metal part that you are powder coating. In this case, in the video that I'm going to show you, it's all about alloy wheels. So the metal is usually heated, then the powder gun is used, and because of the electrical, like static charge, it attracts all of the powder, and then it's heated again to set it in an electrical, which provides a very even coat, again providing a really high quality finish. And powder coating finishes are very durable, whereas dip coating, you could literally probably pick it off, and I'm sure all of us have done that in our time, peel plastic coatings off metals. I know I have. But powder coating, you're going to find it hard to find anywhere to peel this off, and it makes it much more of a strong contact with the metal. So here's a part of a video to show you this process.
The wheels are then hung up and then placed in the oven for 32 minutes for preheat. While the wheels are preheating, we check the powder gun and any paint gun ready for powder coating. Once ready, the wheels are removed from the oven. Powder coating works by applying dry powder electrostatically. This is done by applying an electrode on the rail to create a negative charge, although in our system it's integrated. The powder coat is applied with a positive charge. This causes the dry powder to stick to the surface of the wheel. Once completed, the wheel is placed back in the oven for an additional 16 minutes. While we wait, we prepare the metallic paint, which is then lightly applied over the powder coat to produce the finish. Typically, the wheel goes in the oven 3 times and receives 2 coats of powder and 1 coat of wet paint. Then we apply a powder coat lacquer to finish the wheel. This ensures the best possible finish. Once the wheel is finished, it's cooled naturally on a rail, and then the final quality inspection is carried out.
On average, powder coating can range from $400 to $700, but freshly powder coated wheels can maintain their finish for 15 to 20 years. And for car fanatics looking to preserve their ride, it's worth the price of admission.
There we go. Hope that makes that clear. The last process we are going to talk about is galvanizing. This is a coating process, and galvanizing is an important one for you to have a good awareness of. It's used for products, large metal structural kind of products, lampposts, motorway like barriers, road signs, all different kinds of big metal products, and sometimes some smaller kind of metal garden products, metal buckets, wheelbarrows. So you wouldn't find galvanizing used on a product that's indoors. It's usually used for outdoors, and it's steel that is coated in a layer of zinc. So steel, which is a ferrous metal, coated in a layer of zinc, which is non-ferrous, to protect it from oxidization, from rust. And zinc actually chemically bonds to steel, and it's called a galvanic effect, and it actually gives a lot of hugely beneficial properties. And even when the zinc layer is scratched off, it will still protect the steel underneath. It does that through sort of like a chemical reaction. So this video should hopefully show you that process and give you a little bit more information about galvanizing. So it might be a little bit longer, but I think it's beneficial to show you the process clearly.
Steel is the mainstay of modern construction and has been since the Industrial Revolution began. But left unprotected and exposed to the environment, steel will begin corroding immediately. There are several ways to protect steel from the elements, but none better than hot dip galvanizing, a process that bonds molten zinc to the steel, forming multiple protective alloy layers that protect the integrity of the steel for decades. Valmont began galvanizing nearly a half-century ago and has emerged as an industry leader. We protect our nation's critical infrastructure with one of the most cost-effective and sustainable methods available. Galvanized steel can be recycled indefinitely, has a low carbon footprint, and requires minimal maintenance. Hot dip galvanizing is environmentally friendly. Zinc is a natural and abundant mineral essential for life. In the industrial world, 30% of the world's zinc supply comes from recycled sources, and 80% of zinc that can be recycled is reclaimed. By dramatically prolonging the life cycle of steel, and with low or virtually no maintenance, the galvanizing process significantly reduces the energy and resources needed to manufacture, transport, and maintain these structures. In addition, zinc is an abundant natural mineral that is 100% recyclable without losing any physical or chemical properties. And when combined with steel, there is a 70% recycled content rate, which easily meets LEED credit requirements. In the field of metallurgy, zinc has a special relationship with steel. In the bonding process called hot dip galvanizing, the zinc chemically bonds with the steel to form a series of zinc-iron alloy layers. The final layer is 100% zinc. These tightly adhered layers become extremely abrasion resistant because the intermetallic layers are harder than the base steel. So the protective zinc coating actually becomes harder than and part of the steel used in the structure. Zinc also ages at a rate far slower than steel, and as it does, it forms its own protective oxide carbonate film on its surface. These remarkable qualities of zinc continue to protect steel over time. The second additional shielding mechanism is zinc's ability to galvanically protect steel. When a scratch or abrasion occurs, the zinc coating will not be undercut by rusting steel because the steel cannot corrode adjacent to the zinc coating, even when exposed to the elements. This is why the use of zinc and the galvanizing process provides decades of maintenance-free protection for metal structures, even in high-usage areas and in harsh environments. There are three fundamental steps in the hot dip galvanizing process: surface preparation, galvanizing, and inspection. Preparation really begins at the design stage, and Valmont's team of experts can help you understand the design criteria of the appropriate specifications for your product to maximize efficiency in the galvanizing process. Once the steel arrives at one of Valmont Coating's galvanizing sites, the material is unloaded and placed on racks or fixtures so that it may be transported through the process effectively. The material moves through 3 cleaning steps to prepare the steel to be galvanized. Degreasing is the first step, removing dirt, oil, and organic residues. Then the structure is rinsed. The second step is a mild acid or pickling bath that will remove mill scale, iron oxide, and etch the steel. Then rinsed again. The third preparation step is fluxing. This step removes any remaining oxides and coats the steel with a protective layer to prevent any further oxide formation prior to galvanizing. Once the structure is clean and dry, it is dipped into a bath of molten zinc. As the material is immersed, the zinc will flow in and around the entire structure, protecting all surfaces. While in the bath, chemical reactions take place between the zinc and the iron in the steel to form the series of zinc-iron intermetallic layers and an outer layer of pure zinc.
Right, the next process we're going to talk about is called electroplating. So this you may have covered in chemistry, maybe recently, maybe a long time ago in GCSE, or you may never have covered it. I wouldn't say that you would need to know this in a huge amount of detail, but electroplating is often used to coat a lower cost metal, so something like steel, mild steel, in a much higher quality metal, such as silver or gold. So gold-plated, silver-plated, tin-plated, all of those types of metals are used, and often it's to improve the aesthetics of the product, but also to provide a protective layer, because often the material underneath is going to otherwise oxidize and potentially rust away. So electroplating is the process of depositing one metal onto another metal. So we have a battery, we have a cathode, we have an anode, and we have a flow of like a current going through this solution. So electrons travel from the negative end of the battery through the cathode, and in this instant the cathode is the penny, or the thing that is being electro-coated. And what happens is they travel through the solution, through the anode, up into the positive end of the battery. The positively charged zinc ions that are in the solution are then attracted to the cathode, so they start to stick to the cathode, and they attach themselves to it. And then more positively charged zinc ions from the anode are pulled off to replace those in the solution. So it's complicated. You may have never heard of this before, but just if you've never heard of it, then just remember it is used to coat metals in normally a higher quality metal for aesthetics. It's done with the use of electric current, the cathode, the anode, and even if you just had a few of those key points, you would pick up marks if this question was to come up. Fingers crossed it won't, but electroplating, that is what this process is all about. Anodizing. This is another chemical kind of process, and it happens specifically with aluminium. So this isn't mild steel, this isn't copper, this isn't any other type of metal. This is a specific finishing process for aluminium. It's an electrochemical process, and what it does is it builds up the surface of an aluminium of aluminium, and it makes it much tougher and harder. So you have this electrolyte bath, you have the cathode, the anode, and basically what happens is aluminium has a natural oxide layer that naturally protects it, but anodizing builds this up even more, and it has some other benefits as well. So why do we add this finish to aluminium? It enhances that natural oxide layer, and that results in enhanced hardness. Remember, hardness is resistance to scratching and denting and abrasion, and toughness, so a sudden impact. It improves wear resistance, so durability. But the big thing about it with anodizing, and a big benefit of it, is that during the process colour can actually be added. So this is a colour that would not chip, it would not come off the surface, because it is literally in the makeup of the surface of the aluminium. It kind of becomes part of the aluminium. So you can see brightly coloured carabiner clips and like metal components in lots of different bright colours. My phone is anodized, so it provides colour and some enhanced properties. So used a lot on consumer electronics, phone cases, TV casings, things like kettles and microwaves. If they're bright colours and they're metal, or likely to be aluminium, then they have been anodized. Right, this one's quite complicated, and it took me ages to try and find any information that is kind of simple enough that it's not going to blow anyone's mind, especially if you are revising this slightly at the last minute. So cathodic or cathodic protection is a method for preventing corrosion on steel products that are submerged in water. They could be submerged in water, like boat hulls and pipes, or they could be underground, where they would be exposed to high levels of moisture. So cathodic protection is commonly used to protect lots of different types of structures, ships, subsea equipment, so things that are submerged, harbours, pipelines, anything that is submerged, or a metal structure that is buried in the ground. So basically what happens is you make the metal that you're trying to protect almost part of a, with the anode and the cathode, you make it part of this kind of almost like a circuit in a way. And it's called an electrochemical cell. Those of you that do chemistry are probably laughing your head off at me. Now, I'm sure I'm making loads of mistakes. I do apologise. Obviously, take Mr. Brotherton's teachings over mine, but basically what happens is you can set up protection for the metal by diverting any corrosion that could happen to a different metal. So one of the examples I'm going to give you is something called sacrificial cathodic or cathodic protection. And basically what happens is you coat or you wrap the metal that you want to protect with a more easily corroded metal. So things like zinc, aluminium, magnesium, they are commonly used as anodes, and to do with their amount of voltage that they produce when they are in contact with water, probably losing you now a little bit, it means that they will corrode quicker than the steel or whatever other type of metal that you're trying to protect. So you are basically sacrificing another type of metal to protect the actual product. So yeah, slightly complex. You definitely need some chemical understanding with all of this, anodes, cathodes, electrochemical cells and all this sort of stuff. But cathodic or cathodic protection is all about protecting the product by diverting any corrosion that's going to happen onto another type of metal through this electrochemical sort of reaction that happens. And like I said, commonly used on boats, and if you think they're massive steel products that are constantly in water, and you want to be diverting as much of that chance of corrosion away from the hull of the boat. But yeah, I hope that's given you an understanding of what that means. There is more detail in the revision guides, and obviously you can find more information online. There's some seriously dull videos out there about cathodic protection. I tried to find some interesting ones, but I completely failed. But I hope that gives you enough that even if you were asked about it, you could maybe give some kind of answer that would help you to pick up a few marks here and there. Hope that was useful, and I'll see you on the next one.